Today's problems involve finding normal distributions or probabilities of normal distributions. So the problem reads, assume the random variable x is normally distributed, has a mean of 84 and a standard deviation of zero point 0.5. Find the indicated probability. We want the probability that x is between 71 and 74. Well, the first thing we need to do is change the x value data values into a z-score. The formula for conversion is that z equals x minus mu over sigma. So for x equals 71, it's 71 minus 84 divided by 5, calculates out to negative 2.6. For x is 74, z equals 74 minus 84 divided by 5, which is minus 2. I've listed both z-scores on the standard normal curve. Minus 2.6 is further to the left. Minus 2 is to the right. We want the error in between. So the probability that the data value x is between 71 and 74 is equivalent to finding the probability that z is between minus 2.6 and minus 2. The error all the way out to minus 2 is bigger than the error out to negative 2.6. So therefore we write the probability that z is less than minus 2. So calculate that, subtract from that the probability that z is less than minus 2.6. Using the tables in the text, the first probability is 0.0228. The second one is 0.0047. Subtracting gives us an area or probability of 0.0181. For our next problem, the normal distribution of SAT critical reading scores, for which the mean is 513 and the standard deviation is 124, we want to use that information, and assume the variable x is normally distributed. What percent of the SAT verbal scores are less than 650? Again, we need the conversion formula that z equals x minus mu over sigma. Plugging in the data value of 650, taking out the mean of 513 and dividing by sigma 124 gives me a value of 1.10. So the probability that the data value is less than 650 is equivalent to saying the probability that the z value is less than 1.10. Looking it up in the table, we get the area of 0.8643, or converting it to a percent, convert to a percent by multiplying by 100. And if I do that, I need to correct what I just have down here. And it's 86.4%. Again, occasionally your professor makes mistakes. Part B, if we have 1,000 SAT verbal scores and they are randomly selected, about how many would you expect to be greater than 550? Well, we need to convert the data value 550 into a z-score. 550 minus 513 over 124 gives me a calculation of 0.298. Use the tables in the back of the book, I'm going to round that to 0.30. The probability that x is greater than 550 is the same as the probability that z is greater than 0.30. That's to the right of the z-score. So therefore, we are only calculating the area up to that z-score. So we need to take that area away from 1. The probability that z is less than 0.30 from the table is 0.5120. Subtracted from 1 is 0.4880. Looks like I converted correctly this time. It's 48.8%. If we had 1,000 scores, then 1,000 times that percentage, 48.8% or 0.488, tells me that there are 400 data values, or 488 data values with a score greater than 550.